Good day everyone, I am Josie Bucio and I am here to discuss the point of intersection formula. The point of intersection formula is used to find the points of intersection of two lines, meaning the meeting points of the two lines. Our point of intersection formula is the coordinates of x and y equals b sub 1 times c sub 2 minus b sub 2 times c sub 1 all over a sub 1 times b sub 2 minus a sub 2 times b sub 1 and a sub 2 times c sub 1 minus a sub 1 times c sub 2 all over a sub 1 times b sub 2 minus a sub 2 times b sub 1. And now, let's apply the concept of point of intersection formula in solving problems involving lines. Example, Paul draws a line on a Cartesian plane with the equation y equals 2x minus 1. And his sister draws the line 2y minus x plus 1. Paul says that the lines intersect in the second quadrant, and his sister says that the lines intersect in the first quadrant. Who is correct? Solution. Here's our given equation. Y equals 2x minus 1, which is the line drawn by Paul. And we have also 2y equals x plus 1, which is the line drawn by Paul's sister. So as we observe, these equations are written in a point-intercept form. So we have to convert it into standard form so we can easily identify the value of A, B, and C since the standard form is EX plus BY plus C equals 0. So we have Y equals 2X minus 1. We have to transpose 2x minus 1 on this side and equate to 0. So this will become negative 2x plus y plus 1 equals 0. And multiply both sides by negative 1. This will become 2x minus y minus 1 equals 0. And for the another equation, we have 2y equals x plus 1. Transpose x plus 1 to the other side and equate to 0. So this will become negative x plus 2y minus 1 equals to 0. And multiply both sides by negative 1. This will become x minus 2y plus 1 equals to 0. Where 1 is the value of A, and negative 2 is the value of B, and 1 is the value of C. And also in this equation, 2 is the value of A, negative 1 is the value of B, and negative 1 is the value of C. And now, we have our new equation, 2x minus y minus 1 equals 0, and x minus 2y plus 1 equals 0, which corresponds to the values of a sub 1, b sub 1, c sub 1, and a sub 2, b sub 2, and c sub 2. Now, we have to substitute these given values to our formula, which is the coordinates of x and y, b sub 1, c sub 2 minus b sub 2 times c sub 1 and over a sub 1 times b sub 2 minus a sub 2 times b sub 1 and a sub 2 times c sub 1 minus a sub 1 times c sub 2 all over a sub 1 times b sub 2 minus a sub 2 times b sub 1. The coordinates of x and y equals negative 1 times 1 minus negative 2 times negative 1 all over 2 times negative 2 minus 1 times negative 1 and 1 times negative 1 minus 2 times positive 1 all over 2 times negative 2 minus 1 times negative 1 and simplify. The coordinates of x and y equals negative 1 minus 2 over negative 4 minus negative 1 and negative 1 minus positive 2 over negative 4 minus negative 1. Then, negative 1 minus negative 2 equals negative 3. And negative 4 minus negative 1 will become negative 4 plus 1. And negative 1 times minus negative 2 over negative 4 plus 1. So, this will become negative 3 over negative 3 and negative 3 over negative 3. So, negative 3 over negative 3 equals 1 and negative 3 over negative 3 equals 1. So, the two lines intersect at the coordinates of 1 and 1. And to prove that two lines intersect at the coordinates of 1 and 1, we have to graph it on a Cartesian plane. So here's our Cartesian plane. When we graph the equation y equals 2x minus 1, it will look like this. And when we graph the equation 2y equals x plus 1, it will look like this. So this graph proves that the two lines intersect at the coordinates of 1 and 1. This graph proves that Paul's star is correct, that the two lines intersect at the coordinates of 1 and 1.